Hello everyone and welcome to Practical PyTorch. My name is Daniel and I wanted to create a video to go over metrics, data loaders, models, the things that make the infrastructure around deep learning that's necessary to set up experiments such that they're repeatable and workable and interesting and effective. Not interesting. Let me just make sure my audio is in fact working. Experiments such that they're it is. Look at that. I can hear myself. So I assume I'm going to get about 2 viewers here, which even that would be impressive. But we will see what happens. And I'm not very good at live coding. This is my first time streaming, but we'll see how it goes. So I've got this MNIST data set here, and what I'm going to do is I'm going to develop a data loader for it, maybe a simple model for it with the training loop and metrics, so you guys can see how it's done kind of start to finish. I'm fairly new to deep learning. I do it for a living. I've been doing it for a living for a few months now, and I've got some state-of-the-art results internally that I'm not allowed to share, unfortunately. But it's something that I'm very interested in. I do day-to-day job. I do learning and infrastructure and stuff like that, which is very exciting. But it wasn't that long ago that I really didn't know how to do it at all. So I still kind of remember what it's like to just be very confused by all the stuff out there, and be reading blog posts and watching tutorials and not know how anything works. So hopefully this will be helpful to a couple people, and if it is, then I've done my job. So here we go. Let's do this. Let's just take a look at what's inside the dataset. So this is downloaded from Kaggle, and you can see, okay, we've got a bunch of numbers here. This is not in necessarily immediately usable format. So what can we do to get this into usable format, so that I can actually send this into my model? So what I'll do here is I've actually got a Jupyter notebook ready to go here. So I'll set up a Jupyter notebook, and let's see what we can get set up. So we got Jupyter notebooks, if you guys don't use them regularly, is great. So we'll just call this MNIST testing, right? And now I don't like spaces in file names. So what we need to do is we need to load in this file and see if we can take a look and figure out what's going on. So we'll do fname equals, getting ahead of myself here, from pathlib import path, and let's see here. Alright, so I need this path slash train.csv. Nope, try again. Not CVS, CSV, and then file equals, let's see here, with open fname as f, data equals, and now let's see how we do, read CSV Python. Okay, so here we go. We've got some sort of tutorial here. Okay, so import CSV, kind of saw that coming. And with open, okay, there we go. CSV.reader, delimiter, comma, for row, if line count equals 0, Okay, so this looks promising. So we'll create a CSV reader. And CSV file is just f, delimiter is comma, sure, for row in CSV reader, that looks like it's needed. Print, we'll just do print row, and then I'll just break, right? So, okay, so invalid file. What is going on? Is that an invalid file? I'm pretty sure it's not. ls. So it is there, just doesn't like it. With open fname. Okay, so we'll just try wrapping it in string. I thought open worked with this, but I guess it doesn't. Alright, there we go. CSV is not defined, sure. Alright, there we go, boom. So now we've got this all in here. Now this is obviously just the header row. This is not very interesting to me. So we'll do, print row, and that's annoying. Let's see here, we'll just do rows equals list for row in CSV rows dot append row. Take that out. and now it's going to work its magic. This might take a second. Okay, there we go. So now let's look at the rows. We got 42,000 data points, and let's look at rows 1, right? Okay, so now we've got actual data. So what's the length of this? 785. Okay, so 785. I happen to know the MNIST data set is 28 by 28, which is 784. So let's just look at this one more time. Wait, oh, sorry, it's just len. So you can see here, I think either the last or the first pixel is the actual label, right? So if we do len of rows at 5, it's 0. Let's see if we can get something more interesting. 34, 9. Okay, so it's always between 0 and 9, 6. It's always there. Usually the top row is 0 because it's a black image. So what we want to do is we want to pull this off and then use the rest. So we'll say rows and we'll say labels. So let's rename this data rows labels equals this. For rows, so I'll say data dot append row 1 of, and then labels dot append row at 0. Okay, so I'm assuming a basic familiarity with Python syntax here. I haven't even gotten into PyTorch yet, and I probably won't for another few minutes. But hopefully this all makes sense. I'm just setting up a labels and data here. So that's now running. Okay, so now if I do len of rows, it's 785. That's okay. I renamed it to data. And I hate that part of Jupyter Notebook. It's highly stateful and very easy to mess stuff up. And then if I just do labels at whatever, it's 2. Okay, so that's about what I expected. So now what I want to do is I want to convert this 784 long array into an image. So I need to basically convert this. I think I'm going to need NumPy here. SMP, let's do that. And now I'm going to need to convert this into 28 by 28 so that I can use some sort of a convolutional operation. So let's just NumPy reshape. I think this is exactly what I want. Array to be reshaped, the new shape to be compatible with the original. Okay, cool. So what we'll do is I'll just do this. Data equals item. So MP array of item dot reshape 28 for item in data. So we'll let that run. And I'll explain what that's doing here in just a second. So what I'm doing here is I'm taking each item in data and I'm first putting it into a NumPy array, so it's no longer a list, a Python list, it's now a NumPy array, and then I'm reshaping it to be 28 by 28. So now if we look at data at 0, boom, so now we've got this thing. This is not so interesting. Let's do data at 1. There we go. So this is the beginnings of an image, dtype u3. I don't like that. So let's do dot as type mp dot int the unsigned int 8. There we go. Value error invalid. Okay, so it's for strings only. Okay, so I kind of don't care about this first row. For row in CSV reader. That's annoying. That's really annoying. Is there any way to throw away CSV reader delete first row? Reading the first line. Oh, that's convenient. F.next header line. Okay, so I think dot next might be what I'm looking for. Wait, hang on. CSV reader dot next. I don't think that's gonna work, but what the heck? Okay, that's definitely not gonna work. For row and CSV reader. Okay, so what I'll do is I'll just take off del data at 0, and I'll del labels at 0 to just get rid of that. This is pretty computationally inexpensive to delete at the front of the list like this, but for our purposes it doesn't matter at all. And now this should work. And now, hopefully it's almost done. Hopefully this makes sense for everyone watching. Let me go over to my stream. I have, oh wait, it says one watching. I assume that's me. I am the one person watching. But if not, you know, if there is actually somebody watching, feel free to say something or leave a comment or whatever. Let's take a look at data. Okay, so now we've got this. So now let's do this. Import matplotlib.plt as plt matplotlib. I can never remember how to import matplotlib. Let's see here. Yep, it's pyplot. There we go. So now we've got this, and so now what we can do is, you know, plt.imshow data at 2, and boom, there we go. We've got our data, and now if I do labels, labels at 2, 1. Okay, so let's get a little more fancy. Print labels at 2, and I'll just replace this with I equals, you know, 234 labels. There we go. So now we can, so the point of what I'm trying to show you guys is that this is just a really easy and effective way to play around with your data, understand what's going on, figure out how the data set works. Obviously, there's much more complicated data sets out there that are much more complex than something as simple as MNIST. But you know, if you just go into Jupyter Notebook, play around with a little. This is something I totally didn't realize when I first started out. I mean, this is how easy it is to just play around, get familiar with the data set, and then you can write a data loader based on the data set. So I'm going to go ahead and I'm going to move this off screen now. And now I'm going to start writing my data loader. So I'm going to go over here. Let's see, what do I have? Okay, I've got my everything there. So now I'm going to training, cd MNIST training. Okay, so now I'm just going to do dataloader.py. And so what I'm going to do here is I'm just going to set up a basic dataset class based on the PyTorch tutorials, and which I would encourage you to read if you haven't already. I won't go over them now, but you'll get a pretty good feel on how to use them based on the dataset that I'm about to write. So I'll just do class MNIST data, class MNIST data, def, hang on, can we get color desert, color late evening maybe? It's a little bit better. Def knit self, and so what I'm going to do here is set up, wow, that is just completely unreadable. Back to desert. Okay, barely more readable. I imagine this is totally unreadable for you guys, but I'm just going to power through this for now. I'll try to figure something out in the future, but if you're on a mobile device or something, that is unfortunate. So let's see here. I don't think I can make terminal code bigger. I'll try to figure something out for the next stream. But here we go. So this is how you would do MNIST data. So set up files and file lists, etc. And then def len return the length of the data set. This is usually just your length of your files. If you're doing computer vision, and if you're doing something else, then maybe NLP, then it's your length of your words, index, and then return something about your data. Return an item data set. So this is pretty easy. This is why I wanted to emphasize using a Jupyter Notebook first, because it makes it much easier to figure things out. So really, I'm just going to take a pretty decent amount of this right here and copy it all in and adjust it as needed. So I'm just going to copy this here, set paste, and paste. Okay, there we go. So now I've got all this. One more time, indent, thank you, set no paste. Okay, so what I'm going to do here is, one thing I want to do is have training versus validation. So I want to do training Boolean, and then if training is true, then let's do this here, else we'll just do this. Okay, so now that I've got the file name, this still all stays the same, and then I do want to do that delete nonsense, and actually I'll make these class variables. Okay, so then del self.labels at 0, and then data right here. Okay, cool. So this is just going to set everything up. So now I've got everything stored inside the class, and when I need to use it, I have it available to me for len and get item. And you guys will see how this plays in a moment. If you haven't already checked out a PyTorch tutorial on data loading, there's a pretty good one in the documentation that I would recommend. I'll try to find a link in the description or something like that. So anyway, so we've got labels and data here. Now here I'll just return len of self.data. That's easy enough. Labels also works. I mean, those should be the same because we're doing this. And now all I need to do is some NumPy tricks to get this to return a NumPy array, which I can then convolve on. So what I'll do here is, so here I'm doing this all to the entire list. Really what I need is just this bit right here for the get item part. So here I'll do image equals that, and let's go ahead and just import NumPy as MP. And so this is not NumPy array at item. This is now NumPy array of self.labels at index. So what this is going to do is, if you say, hey, I need the data set, the 83rd thing in the data set, it'll go in here, it'll get the thing out of labels, it'll reshape it, and then I need label equals, sorry, it'll reshape it and save it an image, and label equals just self dot, sorry, this should be data labels at index, right? So there we go. Now we have a NumPy array as an image, and then the target itself. That's what we want. And I'm going to return this in a dictionary. I prefer to use dictionaries. It's very explicit as to what you're getting back, and there's no way to mess it up. I'll explain more about that in a minute. Label, right? Little verbose there, but tends to save headache if you ever run into issues and you forget what you're getting back. If you were just to return a tuple there, it's easy to mess that up as you're using more and more different data sets and stuff like that. So as you scale your training, it does help to have that. So anyway, so we've got this now. Let's delete a couple lines here. This looks pretty good. So this is my data loader, or sorry, data set, right? Let's be specific. This is a data set. So now what I'll do is I'll define some sort of a get def get data loader. And what I'll do here, I'll just return, so I'll say data set equals mnist. So here we'll do training bool is mnist data training, and then return data loader data set. I guess we got to go up here one more time. Batch size int. So this is a distinction that needs to be made between a data loader and a data set. A data loader returns one thing at a time, or a batch of things at a time from a data set. So a data set holds everything. A data loader loads that data. So I'm going to be using PyTorch data loader. And so if we just go here, data loader. So this is what I'm doing. So you pass in a data set, batch size defaults to 1, shuffle defaults to false. Sampler, a bunch of these you don't really need to worry about until you get to kind of more advanced stuff. For now, we'll just focus on the data set and the batch size and shuffling. Actually, not even shuffling. I don't really care about that right now. Batch size, and that is pretty much it. So what I do need to do is I do need to import this. Where's this coming from? Torch utils data loader. So we'll do this. import, or I guess from import data loader. Is that it? Data loader. Yeah, data loader. There's data loader iter. Don't be confused. What we're really looking for is data loader. Data loader iter is an internal thing. You don't really need to worry about that. And so here, I guess I'll just do this. And then data loader right there. Okay, so now we've got a data loader object set up. So now, so we have our data loader. Now we need our model, but that comes in a second. Let's first do our main training loop. So I'll just, vim main.py import torch from torch import nn. I probably don't even need that. So now data, I guess we'll from data loader import. Actually, what did I even call it? I can't even remember. MNIST training. I call it data loader. Okay. From data loader import get data loader, and then we'll just do data loader equals get data loader. Okay, so train and val training equals false. Training equals true, and batch size. I'll just set that to be I don't know, 8 for now, and batch size 8. There's a bunch of different ways to do this sort of thing. You don't have to use a data loader. You don't really have to use a dataset class. This is just what I found that's easiest and simplest. So now we got our dataset. So now we'll do, num epochs equals 10, and then for epoch in epochs for range num epochs. And we'll do for batch in train data loader. Train data, that's what I get for abbreviating. And now we'll say, preds equals, so up here, right, model equals this. We'll figure that out in a second. Model batch at data. And then loss equals loss function of preds batch at label. Oh, a little off there. Label, there we go. Or something like that, right? So to do model and loss function, also unknown. So now let's do the model. And I'm going to be honest, I really have no idea how an MNIST model needs to look. So let's go down here and quit out of this. Yep, I'm not in Git right now. So vim model.py. So now import torch from torch import nn. Let's go over here and MNIST model. And we'll just call this class MNIST model, and then .module def init. This is all standard PyTorch boilerplate. We'll just do this, and then self dot deal with that in a second. Oh, I guess I do need the super init call. All right. So okay, TensorFlow, that's cool. Simple 2D CNN towards data science. This looks promising. Let's check this out. So what I'm hoping you guys can get from this is that you can really just Google around, see a model online, implement it in PyTorch, and test it out. It's really not that hard. So now he's going through his data visualization. Sure. Training and evaluating. Where's the actual model? Okay, so here's the model. Sequential. So this is some Keras code. Go away. I don't want to write a response. That's okay. Okay, so here he's got a conv2d, another conv2d, max pooling, dropout, flattening, and then dense, a fully connected layer, and dropout, and another dense. So MNIST in this case, num categories is 10. So you were trying to predict 0 to 9 digits. So now we need to implement this model right here. So we'll start out with this. Yeah, this should be doable. I'm going to put this on another monitor over here, but I'll walk you guys through it. So the first thing we're going to need to do is I'll just call it conv1 and then conv2d. I happen to know that's the thing. And in conv2d, end channels, or sorry, let's see, what are the input channels is 3. What should the output channels be? 32. I just made that up. No, just kidding, I didn't make it up. It's right here. So if we go back, maybe I'll just leave this here. Yeah, here, let me just do this. There we go. So now he's using this and then our ReLU. So I'll add the ReLU in during the forward pass. You guys will see that in a second. Input shape, don't worry about that. The kernel size, that's right here. So now here we have it. So conv1. Then the next thing they do is another conv. So I'll do 2. And then this time, it looks like they're doing 64 channels. I'm just sort of guessing based on the syntax here. Yeah, obviously for your specific model, you might want to be a little bit more thorough in the dimensions. I'm just sort of looking around for something to test out quickly. Another 32 to 64. And then they do max pooling. That, maybe I need that, maybe I don't. Let's look into, PyTorch max pooling. I spend a lot of time on this web page right here. So let's see what we have. So here's pooling layers off to the left. Max pool 2D, that looks pretty promising. So now I do a kernel size, stride is none, padding 0, dilation 1. That looks all very promising. So I'll do, self.max pool equals nn.max pool 2D. Kernel size, I guess I'll do 3 by 3. And that's really all I need for that one, unless he had more details. Okay, so he's doing 2 by 2, so I'll follow his. And wait, let's add up. There we go. And then he's got dropout. Sure, let's do dropout. Oh, hang on. I don't want go away, Windows. I don't want to talk to you right now. Okay, so I have to. If non-zero R and N. Okay, I don't care about that. How many places are dropout on this? 40 places the dropout occurs. I think I can just find it. It says dropout layers right here. This looks promising. During training, randomly zeros some elements of the input tensor with probability P. Usually the input comes from conv2d modules. What is the difference between dropout, 2D, and dropout? Can't I just pass a tensor in and you just delete some of the items? P0. Alright, we'll try this. Self.dropout equals nn.dropout. And there we go. Dropout. And then flattening for the fully connected layers. So let's see what PyTorch has for flattening. Nothing. Look at that. There's no information. Flatten tensor. How to reshape tensors. Oh, but I have to do some view nonsense. Yep, there we go. That is really stupid. Is there no better way to do this? View nummel. Wow, that's so difficult. Where's the flatten layer? Here we go. What are the people on GitHub saying? Implement a flatten function. They implemented it? So what do they actually add? Flatten takes in a tensor, start dim, end dim. Okay. Does this exist? Where would it be found? It's in A10, which is not what I'm looking for. Test. Torch docs. Add doc string, torch.flatten. Flattens a continuous range of dims into a tensor. Torch.flatten. Okay, let's try this. Python import flatten. Okay, well that's impressive. Random 2 Huh, looks like it works. Okay, that's promising. So now, okay, so I'll just do that in the forward pass. So then I'll do self FC1. Let's go back here. Where is it? Okay, so he has 128, which I guess is his thing, right? That's his dimensions. I don't know what my dimensions are going to be, so I'm going to need to figure that out. Self FC1 equals nn dot, what do they call it in PyTorch? Linear layers. The linear layer, not a fully connected layer. It's a linear layer. nn dot linear, linear. And let's go back to his model. He has, where'd the architecture go? 128. I think that's 128 out. I can't remember. It's been a while since I've used Keras. So we'll just do this, comma 128. And then maybe more dropout, but I'll deal with that in a second. FC2. 10. Okay, so there we go. So then this is going to be 128. I don't know how much this is going to be. But they're getting pretty close. And now I'll do the forward pass. Def forward self x. And so we'll say x equals self conv 1. You guys have seen this before. Honestly, this could just be done with sequential, except I'm going to add in some ReLUs and stuff. So might as well just write it all out. Especially for your benefit. So x equals self conv 2x, and then x equals self dot max pool x, and x equals self dot dropout x, and then I guess should I add anything else here after the dropout? X equals torch dot flatten x, x equals self dot FC1x, and nope, one more time. There we go. And return x. So this should theoretically return a 10 long tensor representing the predictions for each number, which is exciting. So we'll see how this goes. This is going to go through a couple convolutions. It's going to go through a max pool, some dropout. I could add some more dropouts. I also need some ReLUs, so we'll just do this. I'll just use the functional library from torch.functional, sorry, torch.n.functional. Actually, what I want is this. Import, nope, what did I do? Import torch.functional as f. So then we'll say x equals f dot ReLU of x. And we'll just kind of sprinkle that in here. There we go. Got a couple ReLUs, which is nice. And then this will be the predictions. So let's go down here. And actually, let's go back up. I need to go to the train loop. Oh, sorry, I called it main, didn't I? Yeah. Okay, so then from, what did I call it? ls, not where I want to be. mnist training ls from import, I can't even remember what I called it. Model mnist model. Okay. All right, and model equals mnist model loss function. That's a good question. So we're going to get this tensor, and we need some sort of a loss function to compare with the actual label. Let's see what PyTorch has to offer. Where am I looking to go? This is not where I want to be. Here. Okay, so loss functions here. Let's go check out some loss functions. L1 loss creates a criterion that measures the mean absolute value of the unwise difference between the input x and target y. So this is just the absolute value L1 loss is pretty classic, but not really what I want. Mean squared error could work. Let me just scroll through these. I haven't actually thought about this. Cross entropy. Useful when training classification problems with C classes. If provided, the optional argument weight should be 1d tensor. I think cross entropy is kind of what I want here, but I'm not totally positive. Input NC where C is number of classes, or target N. Okay, yeah, I think this looks pretty much what I want. Target N. Yeah, this looks what I want. Looks like, like what I want. So we'll just do this in the main training loop. No. And from torch, import an N. And here we go. So then loss equals, I guess I'll name this something different. Actually, no, I should just name this loss function because it doesn't make sense to call it loss. And loss. And then loss dot backward. I think that's about all I need. Or sorry, no, I need like an optimizer, right? Yeah, just kidding. Totally forgetting things. Live coding is hard. Torch.std. Is it torch.std? Where's your optimizers? Where are the optimizers? Okay. Really what I want is this. Just give me Atom. We're just going to use Atom. Optim.std. Is it just torch? Torch.optim? Where do they give you the import statement? I hate it when they don't do this. Yeah, it's just torch.optim. Excuse me. Okay, so then there's this. So then optim is hang on. Yeah, that's a bad idea. From torch.optim. Oh, hang on, let me learn how to spell here. Hang on. There we go. Let's do Atom. Sorry, I'm kind of fighting with the keyword there. Optim equals Atom and model.parameters. And then optim.step. That's what we're looking for. Okay, so this is very, very simple, easy training loop to set up. More complex is things like learning rate schedulers, weight decay, differentiable learning rates, or sorry, not differentiable, but like different learning rate sections for different layers, stuff like that. But this is very, very simple. And now I'm sure I've made 1,000 errors, so we'll try this out here. Python main.py. All right, invalid syntax right off the bat. Val data loader equals, yep, I need that. Let's try this again. Invalid syntax, batch size, and how is that invalid syntax? That looks just fine to me. Data loader line 7. Return data loader, batch size. Oh yes, you're right, it is invalid syntax. That's not how that works. That's what I get for trying to do annotations. Self data, tab error, inconsistent use of tabs and spaces. Oh god. Okay, line 18. I hate this so much. Sometimes when you paste things in, it just like pastes them in with tabs, and then Python just loses its mind. And I don't know why this happens actually. Let's see. This may be a real hassle actually. Oh, sorry, I forgot to write the file. Yep, this is just gonna keep happening. I bet like all of these have bad tabs. Need to figure out a way to like deal with this. I'm sure there's like a command you can run in Vim that's just like fixes it all in one run, but I'm basically done here anyway, so I'll find that next stream. There we go. Sorry, again, forgot to write the file. Invalid syntax. Oh, right, line 14. Model. So we'll just say it's, I have no idea what it's going to be. It's, I don't know, 49 or something. Let's take a bet there. That's totally wrong. And path is not defined. Right. Data loader. From path lib import path. This is very standard. Don't be upset if you get 14 errors when you run your code. I do this sort of thing all the time, and it just happens. It's just the way the world works. Image. Not the way the world works. Sorry, I'm just kind of rambling here. What I mean is that when you write a bunch of code and then you run it, don't expect it all to be perfect. Nobody's ever is. I've seen really, really smart guys not do so well, but they always fix it, and that's really what makes the difference, is just being able to sit down and fix your code and not worry about the issues. Okay, so what do we have here? Expected 4-dimensional input for 4-dimensional weight, but got input of size 8 by 28 by 28 instead. Interesting. Oh, because it's not a 3-channel image. I'm sorry. This is a 1-channel array, and even then, it's probably not a 1-channel array. It's probably just, yeah, it's just 28 by 28. So there are no channels. There are no channels. Okay, so I'm gonna need to give it channels, and I'll show you what I mean here. So let's import PDB. PDB does set trace. Run this, and so now you're going to get to see the inside of the model. This is why PyTorch is so nice. You can easily just take a look inside. So if I print x.shape, it's 8 by 28 by 28. 8 is the batch size here. 28 and 28 is the height and the width. So really, I want channels here. So if I go into my data loader, what's happening is down here, this is getting reshaped to 28 by 28 by 28. I'm sorry, just 28 by 28. Really, what I want is this. Let's try that. And run it again, see what happens. Okay, so now if we print x.shape, now it's 8 by 1 by 28 by 28, which is what you want. And you don't necessarily have to have that, but it's convenient if you're working with convolutions. It's just kind of the way it expects the data. Let's go back to model here. Okay, so now I need to step through here and make sure all the dimensions are correct. This is the Python debugger, by the way. If you haven't ever used it, I would encourage you to check it out. It's very easy to use, very handy. Google a tutorial or something, or maybe I'll go over it sometime if there's enough interest. X.shape. Okay, so now if I run n for next, it'll go through. Oh, look at that. Conv2D is implemented for Torch byte tensor. Okay, why is it a byte tensor? That's weird. Let's go take a look at data and see what it's returning. Actually, let's go back to main for batch, import PDB, PDB does set trace, x.dtype will show us really the issue. It's uint8, not implemented for byte, which is I guess a byte tensor. Let's check this out. Let's go to data. I think I know where it's messing up. It's this right here. So let's try, I don't know. Okay, so char tensor, byte tensor is not implemented. Wait, no, stop it. I don't want to go there. So let's try int32, I guess. All right, so that should fix this. Someone is texting me. Okay. P batch. There we go. So now we have what I wanted. This is now uint8, and the label is just a list. That might be an issue. We'll deal with that in a second. Next, now we're inside the model. Let's go back to main. Fine. There we go. All right, so x.shape next. Nope, still not implemented because it didn't actually write. So let's run this again. I edited the file, I didn't save it, and that's what you get. You get the same error. x.dtype in 32. Cool. Next. Wow. Okay. That's. Oh, it has to be floats, I think. Data loader. Fine. I'll make it floats. Sure. We'll just do float 32. A little annoying there, but that is something that happens a lot. Data type mismatches are very, very common. I was just dealing with some of those today. And you know, you got to be able to quickly jump around. So now if I, next, cool, finally works. Now if I go next again, model. So now we're walking through the model. It's running all the convolutions. So if I px.shape, it's now getting slightly smaller. So it was, you know, like 28 by 28, now it's 26 by 26, so it's getting a little chopped off, which I'm fine with. Next, relu, sure, max pool, dropout. So up here there is an issue. So flatten. Okay, so this is the interesting part. Px.shape. So now it's 12 by 12, sure. Next, now it's flattened. So px.shape. Sorry, it's not flattened yet. We just dropped out. Now it's flattened. Px.shape. Now it's 73,728, which is kind of a lot. But you know, that's what the neural nets do. It's a lot of data. There we go. So now I've got that number. So just note how I did that, right? So I mean, I kind of just made it up as I went along. I built this part of the model because I knew how it was going to work. I didn't know this number, this 73,000. I just used a debugger to figure out exactly what it was going to be and set that up that way. So now this is going to fail. If I go next, it'll be like, yeah, it's not the right size. And I'm like, yeah, sure, I know. So now let's run main.py and see what happens. No news is good news here because, oh, well, there we go. We got bad news. Expected dimensions out of range. Expected to be in range of 1810. Got 1. Return loss function. Okay, so let's go to main and loss. So okay, import pdb set trace. Let's see what's actually going on here. Running up on an hour here, so I'll probably call it quits and come back to this. I don't want to bore you guys. So now if I preds.shape, okay, so it's a tensor, which is what I expected. And if I batch at label, it is, oh, interesting, 1, 2, 3, 4, so it's 8 long. Oh, len batch, what is going on here? Yeah, sorry. Okay, so this is 8, but the preds are 10. Oh, it's because... Okay, I see the issue here. So the labels are 8 long, but what we've done here is we've... Oh, when I unflattened the tensor wrong. Okay, so let me just explain what I've done wrong here so everybody kind of understands it. These are the labels for the images that I've sent in, 10140073. These are the correct answers. The predictions I'm getting back is just a 10 long tensor, which is totally wrong because the input here was 8 images, and then I convolved and I relued and stuff like that. But then at the end, I just flattened everything out to basically put all images together, which is not what you want at all. Unless you have a batch size of 1, this would work. But basically for any other batch size, this doesn't work. So the torch.flatten is really not what you want here. I want to flatten, but I want to flatten based on the image itself, not the entire tensor. So I'm going to need to go back to this and figure this out. And that's probably going to involve a PDB, our good friend. This is a very easy way to figure this out. Save yourself the hassle. Don't try to think through it. Just run the code, take a look, see what's going on. Built by a sequential container. Yeah. Okay, so sorry. Write this file. No, stop it. Write the file. Thank you. let's see how we can flatten. So basically what I want instead is not a fully flattened tensor, but a slightly flattened tensor. And by that I mean if I px.shape, notice how it's 8 by 64 by 12 by 12. What I really want is this part to be flattened, but not this part. So let's give this one more shot. PyTorch flatten tensor with batches. There's got to be a way to do this. I've tried to do this before, and I remember it being kind of weirdly difficult. Let's try this. What's tensor? Oh, x.view -1. What is this n thing? Shot in the dark here. Let's do 64 times 12 times 12, which is 9216. 9216 dot shape. There we go. Okay, so doing view -1 9216 returns a tensor of 8 by 9216, which is what you want. So that's pretty stupid, but we'll do it anyway. X equals x dot view -1 9216, and we'll ignore the flattened thing, and then this will work, and then this needs to get changed to 9216. Nope, 16. There we go. Okay, so now this will return what I expect it to, and let's try this. Alright, so now if we p preds.shape, it's going to be 8 by 10, which is what you want. And then if I p batch at label, it's this, thing, right? So now I can do, I think, can I just do this? We'll see. Maybe it'll have other complaints. List has no attribute.size. Okay, yeah, so we need this to be a tensor. I don't know why this isn't a tensor. Actually, I think I do exactly know why. Let's do this. np.array. We need to, so this is just a Python list. It's expecting an array. So if I set this to be a NumPy array, the data loader will collate all the data correctly. Probably. Wait, no. Probably. So we will see. We'll see how this goes. And if it doesn't work, then there we go. It doesn't work, so because I need to set the data type explicitly, as type, hang on, there we go. As type, and I think, wow, I don't know what happened there. I think this needs to be a integer. Just have a guess, and if I'm wrong, then we can change it, but we'll see. Okay, so now can I just run this line, and if so, why not? If not, why not? Runtime error, expected object of torch long, but found, okay, there we go. So we do have a data type issue. PyTorch long tensor, what is that, an int64? Yes, int64. Okay, so we go back here, and we'll do 64. Run this. Okay, so this happens all the time. You run into data type errors, and you have to massage shapes into the shapes that the function expects. And this is just part of data science. And I used to be very, very bad at this, and I always get frustrated. And the trick is to just do what you can. Cool. So now we have a loss. So now let's do this. I'm gonna set up a little thing here. Model.py. Sorry, main.py. So this is nice, and I think this is now going to work, but we need to actually, well, first of all, let's just make sure it's right. So write PyTorch simple training loop. Let's make sure I'm actually on the right track here. Training a classifier, yes. Classes, yep. Images, dataloader.next, yep. Imshow, I don't care. optim.step. Anybody got a step? Net.parameters. Oh, SGD. Okay, so this I'm doing right. Good, good, good. Cross entropy loss. Loss is criterion. Yeah, okay, cool. So what I'll do here, for batch in, I'm going to do something I haven't done in a minute. From tqdm import tqdm, and then tqdm, so iter equals data iter equals iter or tqdm train data loader, and we'll do this. I'll show you why I'm doing this in just a second. This is going to be so we can print nice metrics. And so now, you know, tqdm add text to bar or something like that. Add a message. Yes, you can. Set description. I don't think this is how you're supposed to do it. Set description. It doesn't sound right. Let's just try this out really quick. Let me just check this out. Usage, table of contents, usage, module, bar format, unit divisor. Okay, fine, I'll try this. T set description. T.set description. Spell it right. Loss %i. I don't even know what this is. Does this expect a string? Loss plus loss. Okay. So now let's run this and see what happens. Except it doesn't need. It needs to not be T. It needs to be data iter. Let's try that. So this allows the tqdm to run. Got string but expected one of add expected invalid combination of arguments. Got string but expected one of tensor other number alpha number other. What the hell is going on? Time for PDB. Okay, let's see, we're at 57 minutes. Let's see if I can figure this out before we hit an hour. P loss plus loss. Okay, yeah, so it doesn't know how to print that, so loss dot item. Okay, that's probably more what it wants. Okay, I guess we're just gonna have to do it the hard way. Okay, so that's all it wanted after all. String loss.item. Oh, okay. What's the other? Oh wait, I still have PDB in there. So this will allow the tqdm bar to actually print the loss, which is exciting. Cool, there we go. So we can see it is now training, and we can get statistics on how far it is through the batch, how long it's taking, how fast it's going, and the loss itself. So a lot of precision there, probably pretty unnecessary, but you know, never hurt anybody. Okay, so you can see the loss is going down. It's also kind of bouncing around. This net may not be ideal. It may need, you know, higher batch size, higher all sorts of stuff, or a more optimized training regime. There's probably a lot of improvements that could be made here, but you can see how you can get started with everything from, you know, building up a model to, you know, building a data set and a data loader, how you can visualize your data set quickly and easily to figure out how things are structured in whatever data set you're using, and then how to set everything up to, you know, work together and have a simple model in under an hour. Which I think is very, very exciting. This is using, you know, Google Cloud Engine. I think it's you know, a very, very powerful system that allows you to get a lot done. So anyway, I'll look into possible improvements, and I'll probably throw up another live stream sometime later this week. Thank you all for tuning in. This has been a lot of fun, and I'll see you next time. Bye.